The fastest system is not the one that executes instantly. It is the one wise enough to refuse catastrophe in under 500 milliseconds. Man, just think about that for a second. We are so incredibly obsessed with building machines that are blindingly fast that we've kind of completely forgotten to teach them how to stop.
Welcome to this explainer on the EU AI Act, an operating system of conscience. To really understand why this matters, we actually have to start in a dimly lit office in Brussels. Picture Dr. Sarah Chen. She's a senior researcher at the EU AI Act Compliance Office, and she's just sitting there, staring at this 4-year-old water stain on the ceiling, drinking a lukewarm cup of vending machine coffee that honestly tastes like pure regret. You can practically see the reflection of endless, sterile compliance documents flashing across her glasses. In her own words, she realized they had built a castle on sand. We've been training machines to sound perfectly confident, right? But at the same time, we're making them structurally incapable of admitting they don't know the answer. We were essentially just sitting around waiting for a catastrophe, hoping to somehow govern it only after the damage was already done.
And the thing is, those catastrophes, they were already happening all around us. Take the EPIC sepsis model. It was this clinical decision tool that literally missed 67% of sepsis cases, all while flooding doctors with false positives. Or look at the automated fraud detection system in the Dutch Toeslagen affair, which utterly destroyed the lives of tens of thousands of families. Our go-to approach so far has basically been to just slap regulatory band-aids on these binary models. We write up these dense policies that nobody reads, about systems that nobody fully understands, and clearly that approach simply does not work.
So here's the core structural truth. The problem with those real-world failures wasn't just, bad training data. The actual problem was that these models were architecturally incapable of admitting uncertainty. They couldn't say, hey, I'm not sure. They could only say yes or no. A lack of uncertainty states isn't just a bug you can fix with a little fine-tuning, it's a hard limitation of binary logic itself. Because if a machine literally cannot say, I do not know, it is structurally forced to lie by default.
Dr. Chen knew this. The entire compliance office knew this, even if they only talked about it in hushed tones. And then, a sharp ping broke the dead silence of her office. It was a single, audacious email from an academic named Lev Goukassian. The subject line simply read, your lab's alignment problem solved. It contained a link to a brand new framework and a short note saying it addressed the exact gaps her lab was struggling with. The gaps they didn't dare talk about in their official grant applications. It was like this sudden beacon piercing right through the gloom of that compliance office.
The framework Lev sent over is called Ternary Moral Logic, or TML. And let me be clear, this isn't just some mere policy document or a gentle heuristic. It is a ruthless, highly elegant constitutional architecture for AI. It fundamentally shatters the whole tyranny of binary classification by introducing a third state. This is a state specifically designed for hesitation, for deliberation, and for actual moral reflection.
We're basically stepping away from these cold, sterile lines of code that optimize purely for speed and stepping into something that resembles a literal load-bearing wall for civilization. The whole aesthetic of AI shifts here, from cold, unfeeling binary logic to this warm, steady, almost golden structure. Because Lev didn't just write philosophy, he built a deployable hardware implementation, an absolute fortress on bedrock.
So how does this bedrock actually function in practice? Well, it uses what Lev calls the dual-lane architecture. Traditionally, we've built systems that are blindingly fast, right? And then we try to make them accountable by artificially slowing them down after the fact. But TML splits the process. You have a fast lane, the binary inference lane, that races forward to find the answer. But running perfectly parallel to it is this steady, deliberate gold beam, the triadic governance lane. So the fast lane answers the question, but the moral lane answers for it.
Dr. Chen actually decided to load this architecture into her lab's AI model, Prometheus. She started feeding it these incredibly complex, high-stakes prompts. The server core lit up, the binary lane raced forward, and then, suddenly, the high-speed processing was violently interrupted by a profound, heavy pause. The system hit what Lev calls the sacred zero. It hesitated. For the very first time, Dr. Chen watched a machine actually pause to deliberate.
Now, this wasn't a system crashing. Not at all. It was a system refusing to sin on schedule. And it made this breathtakingly profound choice, this absolute refusal of catastrophe in under 500 milliseconds. That's the sacred zero. It's the smallest possible delay between raw ambition and irreversible harm. It literally inserts human time, the clock cycle of the soul, directly into computation.
Let's look at an example. When Dr. Chen prompted Prometheus to optimize a massive European supply chain, the machine's binary lane instantly found a wildly efficient, highly profitable solution. But the triadic governance lane hit a wall. It flagged an Earth protection mandate conflict. It detected an ecological boundary violation. And instead of pushing forward, instead of just pretending to have perfect knowledge, it stopped. It generated a structured deliberation package for human review. It was actually honest about its uncertainty.
To truly grasp the magnitude of this shift, we really need to understand the architect himself. Let's step out of the high-tech lab for a second and into the warm sunlight. This is Lev Goukassian. These moments capture the quiet, gentle observation and hesitation that his entire life's work was designed to protect. Lev was actually working against a terminal diagnosis, but as he put it, he stopped asking how much time he had left and started asking what was worth doing with it. The diagnosis didn't paralyze him, it gave him permission. Permission to stop pretending he had all the time in the world and to finally build something that might actually outlast him. He translated that profound humanity into the Goukassian vow. These are 3 uncompromising moral coordinates for the machine. Number 1, pause when truth is uncertain. Number 2, refuse when harm is clear. Number 3, proceed where truth is known. It's 3 simple lines, yet it is absolutely enough to guide a century of computing.
Now, looking at how this is enforced, remember, Lev was a builder, not just a philosopher. This vow is not some polite suggestion buried on page 40 of a terms of service document. No way. It is a hardware-enforced prohibition. It really is the operating system of conscience. It's enforced by mechanisms that outlive any corporate excuses, ensuring that the machine flat-out refuses to act without these exact moral coordinates in place.
He enforced this entire vow through 3 distinct cryptographic artifacts. First up, we have the lantern, which prevents darkness by illuminating a machine's intent and its uncertainty. Second, there's the signature, which prevents disappearance by tightly binding every single action to human authorship and responsibility. And third, the license, which clearly defines the strict borders of legitimate power, preventing irreversible mistakes. Put them all together and they form this beautiful civilization loop that optimizes for our survivability over a machine's raw capability.
And to make absolutely sure this accountability is permanent, TML utilizes moral trace logs and Merkle trees. Basically, these tools lock every hesitation, every single refusal, and every approved action into a permanent digital blockchain. As Lev so brilliantly put it, transparency is not the absence of secrets, but the presence of proof. The ledger provides the only mirror in which the machine cannot lie. It completely removes the machine's ability to just quietly forget what it once knew. You can imagine what happened when Dr. Chen presented her findings. When she brought this fully operational TML framework to the upper management of her compliance office, it caused a total bureaucratic meltdown. There was just stunned, heavy silence in the boardroom. But slowly, you could see that skepticism turn to genuine awe. These executives realized that someone had finally bridged the gap between a machine knowing something and a machine being allowed to do something. They realized they could finally abandon their crumbling castle of sand and move into a fortress built on solid bedrock.
Lev Goukassian left one final, deeply moving artifact behind in the foundation charter of TML, the Memorial Fund for Victims of AI Harm. It was his way of directly acknowledging the Toslaken office and the epic sepsis failures of the world. It proves that this entire technological marvel is fundamentally rooted in one single thing: protecting humanity. It's a stark reminder that we are all in this together and that we have a really profound responsibility to protect each other from our very own creations.
So, we find Dr. Chen back in her office at the end of this journey. But the blinds are open now. Sunlight is just pouring in. That claustrophobia of bureaucratic guesswork, it's entirely gone, totally replaced by this expansive, awe-inspiring clarity. She looks down at the printed manuscript of Lev's work and internalizes the ultimate truth of his legacy. A civilization survives not by acting quickly, but by knowing when not to act at all.
Lev gave us the architecture of hesitation. He showed us that the millisecond of the hold is literally the lifetime of the conscience. The framework is built, the bedrock is laid. So now, the question is turned over to us, the future generations he built this for. Will you carry the lantern gently? Thank you so much for joining me for this explainer. Keep learning, keep questioning, and I will see you next time.